She left the meeting. Oh goodness. Okay. Then I'm gonna give her at least one more or 2 more minutes before we get started because I think she's having difficulty. She couldn't speak. Oh, there she goes. You back, Danny?
Yeah, my thing. I kept
Had some
disconnecting.
issues.
Yeah.
Okay, you fixed it though. All right. So what I was asking you was, where are you at far as what we did yesterday? Did you open up this document from yesterday?
That. Oh,
Yeah.
yeah.
We
I think
started on it yesterday, right?
yeah.
So did you find it in your Google Drive?
Hold on. Yeah, I did.
All right. So can you share your screen so I can see where you are? And do you have a cell phone or something?
I have a cell phone.
Okay, so like the guys did in period one, they took pictures of what they missed in class yesterday. So I need you to share where you're at so I can see where you need to, begin. Isaiah is pretty much through, and as soon as you take all the snapshots, I'm gonna try to talk about how to do the problem I assigned for Monday. So you'll have an
It didn't save
opportunity.
all of it. It only saved half of it of what I wrote.
Uh, okay, I just want to see where you are so I know where to scroll up at.
Yeah, I don't know. No,
So
because
I
I
know where
no, I
to
did
start.
more, but I don't know why I didn't save the rest of it.
Oh,
Cause like I have this, but the rest is gone that I had over here.
okay. All right. Well, okay. So you're up to the definition part.
Okay.
So strategy, but there's a lot more you got to take pictures of. So here's what I want you to do. See this part that you missed or you don't have. I'm not saying you didn't do it. Let me share,
Okay.
and you could just take a snapshot and type it up later on so you can turn it in by 8 p.m. tonight.
Wait,
Okay.
what part? Cause I did take pictures of what's it called? Yesterday, I did take pictures of some of the notes.
Right. For this.
Yeah, for that, yeah.
Okay. So like I said, take a picture of this and then tell me when I can scroll down because this
Okay.
is we got a lot of steps to go through, and then there's pretty much a lot to do. I'm gonna start you off, and we're gonna finish it up on Monday because I want you
You can
guys to have
scroll
time to review for
down.
the quiz. Huh?
You can scroll down.
Okay.
Oh, you could scroll down
Huh?
even more.
What did you say?
You could scroll down more.
Scroll down.
Yeah, you could scroll down. You could scroll
And
down.
the video of all that we did, I want you to go back and review it. Is how we got to this, so
Mhm.
you can check that out. But first, type everything up so you can submit it.
Yeah.
And if you got questions about it, you can check the video, or you can always message me on Edsby. Did you get this part here?
Yeah, that part. Yeah, I got.
Okay, I didn't know if you did. All right, now this is part B we did last period. And
Okay.
again, I want to get you guys started, so I'm gonna get you to copy everything down on your phone by picture, and then I'm gonna see if you can type it all back up. And scroll down.
Yeah, you could scroll down.
All right,
You can scroll down.
that's it.
Alright.
So that's the entire problem that we started on yesterday, and this is for the 22nd, I want to say. So that's yesterday. So make sure you type it all up and submit it. You can't send me pictures, dear. You got to type it up, okay?
Right.
All right.
Okay.
Yeah, you kids are crafty. All right. So what was I about to say? We're gonna do the next problem, and let me change screens. So in today's class, you'll notice on the 27th, which is Monday, there's this problem. So what I want you to do right now is start a new Google Doc, and let me get in the right account. And I'm just establishing a new Google document. All right, and then you're going to name it. Don't forget to do that first because you want to be able to find your files. If you don't name your files in the Google Drive, you'll have 1,000 untitled documents and you won't know which one is the one you need for the quiz day, right? So this is the do now. As of 27th, I know it's not today's not the 27th, but this is when the problem is assigned. So you got a head start this weekend to try to at least type it up and get it ready. So hopefully when we finish it all the way off on Monday, all you got to do is just fill in the missing parts. So that's today. We need a header. So I'm just going to cheat real quick. I'm going to go back to my other document. That's the beauty of being in Google Apps. You can always find your work. And this is for the 27th. You guys should have established a new Google Doc like I did. You, Danny, you would put period 2. Isaiah, so you can put it in both categories because you got periods 1 and 2. All right. And then next, you, of course, what? You need the problem. Okay. So you guys about maybe 3 minutes to catch up with me. Set a timer. You need all this typed up so far. Okay. That's the problem. Two more minutes. So I'm going to go over the problem again, but you guys will have the opportunity to get a head start on it. So you can go back and use that period if you finished already as a review day for the quiz. So we can go back through all the problems or as many problems we can do in that hour that you may not have turned in, you didn't understand, like substitution method, right? A few people asking me about that. So that's what I'm trying to get a head start on Monday today in period 2. And that way you guys are caught up at least with that day and we can do reviews. So 30 seconds left. Do you have as much as I have on my screen typed up? You should have this much. I just copied the problem from Esby into my new Google document. Let me blow this up a little bit because we're going to work on this. All right. Okay, so let's jump into it, right? Now, this is basically a lesson on motion in 2 dimensions. And what do I mean by 2 dimensions? Well, we have a dimension of horizontal and we have a dimension of vertical. So let me see if I could paint a picture. I'm going to go back to the same simulation system and open a new tab because I want to see if I can find a way to save that for later. You're going to go to Fetch Simulations, and this is a participation point moment for you both. So Isaiah, you can cue this up or get it ready because I got another activity for you guys. And Danny, I'm going to put the link to get to this site And you might want to resize it so you can see your work and work on this. Because in a minute, I'm gonna have you guys share out for participation points what that looks like from what I did on your screen. All right, so let me put this over here. And you should see it in the chat section of your Google Meet. You just click on the link to get there. For Isaiah, he got it bookmarked already, so I don't think he needs to click on the link. So, Danny, you can say yes or no, or I'm having trouble. Were you able to get to that
Oh yeah,
link?
I got to link.
Okay, so you got in there. All right. So the next thing you want to do, we'll come back to the problem, is you're going to click on simulations and you're going to go to physics. All right. Now,
Okay.
this was, if you check the video, this was participation points for having a circuit set up in here. But what I want to focus on, if it's in the physics section, because you're doing something else, is what happens for vectors, because that's what we're dealing with in this one. So this is a motion in 2 dimensions. This should help. I wonder if you can load this. I tried it out, but it says Java, so I'm worried. You might not be able to load this, but you might be able to draw. All right, so if I drag this, you see that vector?
Yeah.
So these are dimensions. You notice when I drag one, the other has a different reaction, right?
Yeah.
So this is where we're going with it. And this is, I want you to click on the same one and see if it loads real quick. I've tried this out, but it's still Java based. So I'm worried if you guys can install it or see it. So where did I go? Let me go back. I went to this simulation in physics that's called motion in 2 dimensions, you guys. So I want you to try that out. Let me know if you're having trouble getting there because I can back up and show you what I clicked on to get where I'm at.
Yeah. Can you back up
Yep,
and show
sure.
me what you clicked on?
Okay. So I'm going back a screen. And are you here?
Yeah, I'm there.
Now, if you scroll all the way down and just look for it, there's a simulation. These are all simulations,
Mhm.
but I'm looking for the one that says motion in 2D, which is here. Did you
Okay.
find it?
Hold on. Yeah.
All right, we're going to click on that. And then you see the little play button. I want you to click on the little play button and see if it starts up for you.
Okay.
How's it coming, Danny? Is it working or is it giving you an error
It's
message?
loading.
Oh, it's loading? Okay, cool, cool. Can
Yeah.
you share your screen? I want to make sure that works because we're using this stuff next week, and this is also a trial run of how everything goes together. So share your screen, and I want to see you try to load it. Let me stop sharing. All right, now I want you to share yours. Isaiah, were you able to get there and start it up? You can type yay or nay. You type in 2-letter words. Yeah, yeah. Oh, he said yeah this time. Okay. All right, so this is still loading. That's a good sign. Just give it a moment. Yeah, because your job, it says jar is loaded. Okay. Main is starting. So Isaiah, you should at least be at this screen. It went away. What happened over there, Danny?
I have no clue.
Oh, okay. So don't refresh. No, leave it alone.
Okay.
Let it load. Let it load. Because it's got to sync. There it goes. It's
Oh,
got to
okay.
connect. It's got to connect to all the technology. Oh. Okay. Yeah. Isaiah says it's working. Thank you, sir. All right. So drag that around,
Oh,
and you see the 2 dimensions. Now, one
yeah.
we can call X, and one we can call Y. You understand?
Yeah.
So today we're going to do a little trigonometry. And the reason we're doing trigonometry is because we're dealing with different dimensions of motion. So this is what happens to a baseball. You got the participation points, Danny. I want to see if Isaiah can share his. So
Yeah.
you can stop sharing, dear. Um, Isaiah, can you share your screen and simulate what we just did? There you go. Thank you, sir. And all right, cool. Thank you, sir. Thank you. All right, I see it. Okay, so now we have a visual of what's happening in this math problem we're doing. I tried to make sure I get some more visuals, but it's tough to do with the basic stuff. Now we're getting to the applied mathematics, which is engineering mathematics. So the things you're going to need to know is vector conversions for length and angle and how to calculate the components. What does all that mean? All right, let's go back to the problem. So you should see something on your screen. And waiting for my monitor. Okay, my monitor's updated. Okay, so now I'm gonna resize this because that was for participation points. We're gonna get into the meat of Monday, which is the problem itself. So what do we do here? Well, we need to first define our strategy or what we're going to use. So vector conversions. Let me see if I can find a visual for you guys. Now, a vector is what you saw. Those are basically those arrows, but they mean a lot more in math. You have a vector in robotics. You have a vector in Scratch, vector sprites. But these are things that have different components to make up a system. Now, type vector, and that's a company, but this can go dictionary. I don't want dictionary. I want some visuals. So vector conversions. I type just that bit in. You'll see that that's still photos. That's not it. Where is the one I was looking for? All right, so I'm not going to find it. But when you're trying to find it, you will use this equation, all right? And it comes from trigonometry. So let me start with trig. There we go, trigonometric functions. And don't get scared. This is still math, but it's just another step up. It's building you guys up for the real world. So in trigonometric functions, the ones we're going to focus on, and usually if we had a book, it'll be easy for you to see. But the one we're going to focus on is sine and cosine, right? So you see here, and this is a great example. And put this in the chat so you guys can review it. I know it's wiki. It's not the best, but it's the quickest one I can find for you guys. So I'm going to put this here, and you can review it on your screen for later if you want. You can't see all that. But what I want you to focus on is this over here. If you can click on the link in the chat, you'll be on the same page as me, and you'll see it better. We have something that handles our vertical, which is sine. We have something that handles, when I say something, I'm talking about the trig functions or operations, and something that handles the x or the horizontal, right? So we're going to use something called theta again for angles. As you can see, that's theta, that's theta. So when we do the Google Doc, you'd be like, what is that? Is that a zero? No, I'm talking about theta. I'll try to use theta, but when you're using the math, you want to use a symbol like this because it refers to this angle here, which looks like 45 degrees, if you can see what I'm pointing at on my screen. All right, so we're gonna do just a little bit of this, but not a lot. Go back to our document, and that was an example of the trigonometric. So I'm gonna call strategy, right? Move my stuff out the way. So strategy. Use the trigonometric functions. I spelled trigonometric. Yeah, I did. Okay. That's why I do things in Google. All right. in Microsoft Word. All right. Functions such as the first one we had was what? When you saw that, that was cosine and sine. All right. Now these are two trig operations that you don't have to worry about how they work until you get into higher math. But for the basis of this problem, to introduce how motion works. So we did motion in one dimension when we calculated how fast someone was going, what was at rest, so on and so forth. But what if you have something that has more dimensions, like a basketball or a baseball or just a projectile, even a human being? They have multiple dimensions. So we're going to deal with just two dimensions of this thing moving. So this would be known as I should put that in the center because that's your notes. Cosine, and then theta. We go to insert, special characters, and we're going to not use arrows. We're going to use math. So if I look at the math functions, I'm looking for theta, and I don't see it yet. I'm looking. I saw it the other day. Where are you at? Maybe I should search you. Is that what I did? That's what I did. Ooh, there was a quicker way. I like this one. Yeah. So that's theta. And if you wonder what I did, I typed theta in there. So maybe I should type that for you so you can search it in your characters. So, because it found it quicker for me. So the way to say that is cosine, and inside of it, theta, which means the angle. And theta is a Greek letter, just like the alphabetical or US lettering system. Greek has its own lettering system. All right, so what do we do next? Well, we're going to take this here because I don't want to find the sine again. We got to do the same thing for sine, right? We'll put this here, but it's going to be sine, S-I-N, like we had in that wiki article you saw earlier. And this means, maybe I shouldn't say equal, it just means. So sine, and then parentheses theta. Okay. So far, so good. I'm serious about that because I want to say it means. You could say it's equivalent to, but I want you to understand what it means. Okay, so far so good. Now there are things we got to add to this. I just wanted you to not be confused about the trig values and what they are. But now we got to use some physics to calculate things. So we need something called the actual length. And that's, we're going to call that R. So the length is what they give
Wait,
you.
I got a question. Real
Go ahead.
quick. With the little O thing. Wait, where'd you find it again?
Theta. Yep. Okay. I knew that
It was
question
in
was
special
coming.
characters, right? But like what
Yep. So
section?
hit insert, Danny. Come down to special characters like I'm doing. Can you see what I'm
Mm-hmm.
doing?
Yeah.
Okay. And then you see this box pops up, right?
Yeah.
Now, if you click on symbol and search for math, it'll give you the math characters. But then you want to come over here in this search bar and type theta like it is here, Theta, and it should find one of these symbols that looks like the one I have on the screen. Did you do that?
Yeah.
Did you find it? Because if not, you can share your screen and I can try to help you through it. Because we're going to be using theta a lot
How's
throughout
it
this.
called again? What is it? Beta or what?
Theta is, so it's TH, it's right here. Let me
T
highlight what I
okay.
said. Huh?
Okay. Okay, yeah, I see it.
Okay. Isaiah, did you find it okay or you had trouble too? Mm. All right, sir. I'll take that as a confirmation. All good. So let's keep going. The next thing we had to talk about is the length or distance in here. It's usually referred to as R. So let's write that out. From our technical calculations or definitions of vector conversions, it would be R X for the X or horizontal, right? And R can be, like I said, let me specify that. R, lowercase r, is simply, it won't let me lowercase it, but, oh, there it goes, is the same as saying length, so means length. And this length can be in either the x direction or the y direction. So length in terms of x direction or y direction. More specific for you guys. So that is for our vertical, that's our y, and our horizontal is x. Okay, so that's clear. Because when I use XR, XY, I don't want you to be like, now what does that mean? All right. What you mean, Mr. Tyler? I've been hearing that for 5 years. Um, so you know those are actual vectors. All right, so Rx is equivalent to, and it's not the Rx I wanted. It's thinking about medicine when it did that. Ah. Okay, okay. That's how you fix that. I just learned something. And then we want to say, how do we find it? Well, we take our length, R, and that's going to be multiplied by, what did we say earlier? Where is it at? Cosine theta. Because I said your cosine, if we go back to that article, that's what you get right there, right? So let me switch right back so you see it. Our cosine handles our x or horizontal. So let me come back to this and clean it up. This is usually subscript. This is a designation of what you're working on. There we go. So that's the way it looks in the book or online if you find the equation for it. The next one is going to be what? Well, you just take this again, and guess what's going to handle the vertical or up and down? It's going to be sine. There. And this is sine. And not sine. That's the actual word, but the math thing is called that. And this is y. No. Come back here, you. Why does that look off-centered? I don't know why. All right, that works for me now. It's having a moment of pettiness, I guess. All right, so now we got the calculations, but here's where the problem changes things. Problem only says, hey, you're dealing with distance. Well, distance is the same as, your R or length. So for the sake of this, because the problem is talking about distance here, so your displacement vector for this trip has a length of 173 meters and points at an angle of 28.9 degrees above the horizontal axis. During the ride to the top, how far have you gone in the horizontal direction and then in the vertical direction? So we're given a length, and the length can be understood as a distance because we're talking about a ski slope. So I'm just going to take these. And the only thing I'm going to change with it is talk about it in terms of distance. So what do we got? We got same values, but now with distance, distance, and distance, and distance. So all of this up here is just notes on how to do the problem. This is what you will find in a trig book. This is the physics portion, right? Now convert to an equation with respect to distance from above. Okay. So now we're at the part where we can start setting up our known and unknown values. Okay. So y'all got a lot covered today. Shoot, there's not much left to do to the problem actually, because now all we do is just set up our known and unknowns and calculate this stuff using these two here. So I'm gonna pretty much let you know the change because I'm gonna come back and use that. And we got to set up our known and unknown. So let me cheat a little bit because it's 10:39, and I want to finish as much as I can and then let you guys go in 10 minutes. So where are we at? So I want to take known and unknown from here. This is from the previous problem, but you don't need to have it if you don't have it up. You just type known and unknown like I'm doing. And now I got to say, what's in the problem that we know? What do we know? It's always the question you want to do in math or physics. What do we know? And then you always be like, unknown. Well, what is the problem asking me? So it don't look like it's too much because we need the horizontal and the vertical. So we know that's our dx for horizontal, and that's going to be our dy for vertical. But what about the problem itself above? It says you are given a length. So a length, right? So that definitely means what? Let's come down here. That's that little d we was talking about, that little distance. Can you stop doing that? You just did it again. There we go. I'm learning you. So that's what? A distance of 173 meters. So I'm just going to take this from here, plug that in. And what else are we given? It said points at an angle, right? So that's our theta. We'll take this right here. And I'll put that. Where did you go? Here you go. Still tripping. Okay, come here. Ah, and that's going to be what? What was, I forgot the angle because I was editing that thing. It's 28.9. And this is measured in degrees. Which is why we have to use trig, right? So what else? Did they give us anything else? They gave us a distance. They gave us the angle. I think we have enough to begin, right? And what are we trying to solve for in our unknown? You come over here. Remember, I told you we're trying to find first dx, the distance in the x direction, look subscript. Ah, better. And then we have what else? Question mark is going to be measured in something called meters, right? Because that's distance. And we got to do the same thing for our y. Okay? So it looks like a thing of beauty. Now we got to do is calculate. So now use putting this here because I'm about to reword it for you. Okay. So that's what we're going to use. And right at this point, it's going to be plug and play, right? A video game or something. So what do we know? Well, just look above. We have our distance. So I'm going to take this. And that's going to be equal to a value inside of it because we have all the values. We know distance is this here, right? And we also know our angle. And that angle was 28.9 degrees. Now, degrees can be written correctly as, I'll show you, as another mathematical character. You can write it like this, or I can write it like this, which is where degrees, see if I can pull that off, insert, and we're in math. So I'm gonna type degrees, and there she is. That's what I wanted. So that's exactly what degrees would look like mathematically, but I just wrote it out so you would know what I'm talking about when you're doing trigonometry. All right, so let's calculate it, right? We're going to use Symbolab for that. So I'm going to need this part here. And then I'll put it together one more time. But this time, I'm just going to leave it in meters because that'll be our final calculation. Meters and cosine, since it's degrees, is almost dimensionless. It'll still be meters. This is just a function that changes the angle of what you're measuring. So if that's the case, I can put that here. And instead of meters being here, it'll be here. So what does all that equal? All that equal, huh? Let's find out. Come to Sum Lab again. Plug that in. And it worked like a charm, right? Let's see if it works like a charm. It did. It's down here. So it's 173 times cosine of 29 degrees, 28.9 degrees. That is equivalent to, let's come back over here. Our, what is it? Take that out, and it's 151 point, and it's 4555. So I'm going to say 46 meters. Highlight that. I'm going to underline that and bold it. And next, what do we have? Well, we got to figure out dy, right? Well, that's similar to what we did a moment ago, except we're using sine. So I can just take this part and change everywhere cosine is with sine, right? I also got to change the x parts too, I think. Yeah. So let me edit that for you because I'm coming up on time. I'm doing good. It's y. And this video will be available by 2, so you guys can go through and finish it. But I'm pretty happy that I was able to finish the entire problem today with you guys, so we can review for the quiz coming up at the end of the program. Okay, so now the angle doesn't change. The cosines do, because now we're calculating for height or vertical distance, or dy. So let's go ahead and calculate that out. And that'll go here. And what do we get? Well, it looks like you get 83 point, what is that? 6, I want to say 61, because it's 607. So we're gonna round up and just keep it to 2 digits. We don't want to have like a long line of numbers. Always round it to just the last 2 digits. Leave the whole number if it's a whole number, but that dot, anything afterwards, only take 2, and you do that by rounding. All right. If it's a 5 behind this 0, I mean 4 behind the 0, it stays 0. But since it's a 7, it needs to go up. So that becomes what? What do we say? 83.61. I'm going to bold that and underline it. And that's pretty much it in essence for Monday's problem. You might want to get a jump start on getting this done. So when you come to class, we can just review. All right. You guys got any questions? Because if you don't, you're free to go to your next period. Well, you guys are going to be with next period anyway. That's why I keep saying that. But you can use this time to, you say, Mr. Tyler, scroll up, scroll down. I want to take a break. It's fine, because we're at that point where we've powered through the entire problem, and now you got to do is get ready for next period, which is it's a lot more Scratch today. And this time, I think everybody's on Scratch online, so it shouldn't be difficult today. Meaning we can share out. Isaiah said all good. So Isaiah, you can just start setting up Scratch, and we can start talking about that the next period, and we will start promptly to give students time, because they might not have a break like I'm giving y'all. We're going to start 10 minutes after again. So that translates to 11:10, where you guys got to come back to class, and we will be starting all together at the same time. Okay. Danny, did you have any questions? You didn't say nothing. Like, you didn't even scroll up. Did you get everything?
No, I'm fine. I'm good.
Okay. All right. So you're just working on typing it up.
Yeah.
If you guys are smart, you'll hurry up, type it up, download it, and send it today. So you're not worrying about did I do it. Okay. So just an idea. I'll see you guys at 11:10.